Welcome to an introduction on statistics in medicine. Now, as a doctor, you're going to be ordering thousands of tests and interpreting them. Now, unfortunately, our tests are imperfect. Not all positive results mean the same, and not all negative results mean the same. So it's important that you understand the characteristics of a test as you're A, choosing them, and B, interpreting the results. To start, we define the characteristics of tests based on kind of plots that look like this, where on the left side you have your testing results, so did you test positive or negative, and on top you have your disease results, right? Did the person really have disease or did they not? On this bottom corner are all your totals. So in this case, we have 100 total participants, 50 of them tested negative, 50 of them tested positive, 50 of them truly had disease, and 50 of them didn't have disease, okay? Now, the real meat of how this test defines is kind of in the center here, okay? So we break this down by defining true and false positives, okay? So in this case, these 50 people tested positive and have disease. So these are going to be your true positives, right? They really have a positive result. Here are folks in this bottom, folks who tested negative and in reality did not have disease. So these are going to be your true negatives. Now, to the left here are people who, although they tested negative, in reality have the disease. So these are going to be your false negative. That negative was a false result. And on the top here are going to be your false positives. Right? These are people who, although they tested positive, really don't have that disease. Now, obviously, you want all your folks to be either true negatives or true positives. And we'll go through some examples later. But first, we want to describe how to describe these tests other than, showing the data every single time. And the two main points we look at are going to be sensitivity and specificity, okay? Now, I'm going to define these in basically fractions. So sensitivity is described as the proportion of every single person that truly has disease, so positive disease. How many of them are you able to capture through your test? How many of them test positive? Okay, so everybody who has disease, all these 50 people, okay, how many of them end up in this box? All right, so the way you can write this is also how many true positives are there and the total of true positives plus false negatives. All right, so how many here end up in this top box? Now the reverse of that is going to be your specificity, and this is going to describe of everyone who does not have a disease, right? Negative disease. How many of them truly test negative? Okay, of everybody here, how many of them end up in this box? So the way to write it is true negative amongst everyone who is true negative plus false positives. Again, false positives are people who truly do not have disease, and false negatives are people who actually do have disease. Okay, so we can analyze our test here. Our sensitivity is going to be, in this case, 50 true positives over 50 true positives plus 0 false negatives, which is going to be 100%. Right, this is a perfect test. And our specificity is going to be 50 true negatives over 50 true negatives plus 0 false positives, 100%. Okay, perfect tests. Now, the next concept we kind of look at is why do we choose these tests? And we go through two things called SNOUT and SPIN. These are acronyms. Well, not really acronyms, they're pseudo-acronyms. But basically, SNOUT says sensitivity allows you to rule out, SPIN. Specificity allows you to rule in. So, in this case, high sensitivity tests are able to rule out disease, right? And what that means is if I have a test that's very sensitive, and really sensitive means of everybody who really has that disease, I'm able to capture them. I'm able to take them in that test. Then if you have a negative test, right? If you have a negative test and a highly sensitive test, I'm pretty confident you don't have the disease. I can rule that disease out. The opposite is going to be SPIN. So in a very high specificity test, I have a very specific test, I can capture everybody who doesn't have that disease. In this case, if you have a positive result, I'm pretty confident I can rule you in, right? My test is good at getting everybody that's negative. So if you have the positive test, I'm pretty sure you have that disease, okay? Now, let's work through some examples of some imperfect tests, which is kind of what you'll see a lot. So we'll look at this one first, okay? Again, we tested 100 people, and you can see the distribution looks a little different, right? So we'll start with our sensitivity, right? So sensitivity is of everybody who has the disease, how many of them are true positives, okay? In this case, 63 over 63 plus our 7 false negatives, okay? That's going to be 90%. So in this case, we're pretty sensitive, right? We're able to capture most of the folks who really have disease. But what's our specificity? In this case, we have 15, right? 15 true negatives over 15 true negatives plus 15 false positives. That's going to be 15 over 30, or 50%. So in this case, our sensitivity is not that great, right? We're able to capture the bulk of people with a positive result or positive disease, but we're not really good at getting everyone who really has negative disease, right? Now we can look at a different example here. In this case, our sensitivity, again, true positive over all positives of disease is going to be 40 over 40 plus 40, which equal 50%. So here we're not really that sensitive. We can't capture everybody who has disease. But what's our specificity, right? In this case, we'll look again on this side. So if everyone doesn't have disease, so of the 20 people that don't have disease, we're able to capture 19 of them in our true negatives. In this case, we have a 95% specificity, right? So again, if we zoom in, you can look at our tests, right? Here, if we look at our negative disease column, the bulk of the people end up in this true negative, right? So we're able to say this is a pretty specific test. Here, the bulk of the people on our positive disease side end up in the true positive, which is what makes this a sensitive test. So if we go back to our spin and our snout, right, and a really good sensitive test, SN, is able to rule out, right? Over here, we have a very specific test. And this is something that's good at ruling in. So an example of this is if we look at our management of tuberculosis, right? Not all times do we use the same test to test for tuberculosis. So let's say you have a population of a lot of healthy people, and some people have tuberculosis, right? And you want a good test to say, hey, you really don't have tuberculosis. You don't have to worry about it. Me as a doctor, I don't have to worry about it either, right? You want something that can really rule out. An example of that is going to be something like our PPD, right? That annual injection, or not annual, but that regular injection that people put under the skin, right? That test has a very high sensitivity, right? I'm able to capture almost everybody who has real tuberculosis with that test. But it's not really specific, right? Some folks get a positive PPD that don't really have tuberculosis, right? But if my job is to rule it out very quickly, then a good test would be the PPD, right? That's why we use it in populations for screening. Now, on the opposite side, we want, let's say you're about to start treatment for TB, and you have to give a lot of meds with a lot of side effects. In that case, you want to make sure you really have that disease. So an example of this would be kind of your TB culture, right? Where we go in your lungs, we get a sample of the junk in your lungs, and we grow it in a petri dish, right? So something like that has very high sensitivity, right? We know that if you have this truly negative test here, you really don't have it. And if you really have a positive test, then I can say, hey, I think you really have TB, right? So I can rule it in. So again, high sensitivity tests allows you to rule things out. High specificity tests allows you to rule things in, okay? Now, the next part of this, the next part of statistics is going to be your predictive values, all right? Which is kind of a reverse of how you approach sensitivity. So we have positive predictive value and negative predictive value, Okay, so while sensitivity dealt with of everyone who had disease, how many of them tested positive or negative, the predictive values look at everyone who tested positive and we go backwards. Okay, so an example of a positive predictive value is if everyone who tested positive, right, people with a positive test, how many of them really have disease? Okay, and we're looking at it instead kind of in this direction. Okay, so we can kind of erase this stuff here. So what we're looking at with this positive predictive value is if everyone who tested positive, right, how many of them actually ended up here? And so the equation is going to be true positives over everybody that tested positive, which is going to be your true positives plus your false positives, right? This box, you're looking in this direction, okay? And again, in our predictive value here, our positive predictive value is going to be 50 over 50 plus 0, which is 100%, right? And all this is saying is that if you tested positive, so again, we're looking at a test now. We've gotten our result. It's a positive result. Now that I have this result, how confident am I to say you really have that disease? In this case, if you have a positive result, I'm 100% confident you have a positive disease, okay? The opposite is going to be here, your negative predictive value, okay? So in this case, it's everyone who has a negative test. You tested negative. How confident am I saying you really don't have that disease? Okay? So in this case, we're going to look in this direction. Okay? So of everyone who had a negative result, which is going to be your true negatives and your false negative, how many of these folks are truly negative? Okay? So in this case, our negative predictive value is going to be 50 over 50 plus 0, right? Which is also 100% because we have a perfect test here. Now, let's look at an example of a more realistic test, something like this, okay? So let's say we want to find out our positive predictive value, okay? In this case, it's going to be your, of all the positive results, how many of them end up here, right? So your true positives, 72, over 72, plus your false positives, plus 8, okay? So 72 or 80 or 90%, right? And I'm pretty confident in this case, if I had a positive result, so if I had this positive result here, I am 90% sure you're in this box. You're in a positive disease box. Now, the flip side of that is going to be your negative predictive value, okay? In this case, we're going to do your true negatives over everyone tested negative, okay? So 10 people had true negatives over 10 true negatives plus 10 false negatives. That's going to be 10 over 20 or 50%. So now let's look at our test here. If you tested positive, if you were, let's say I got a test, I ordered a test. If you're positive, I'm 90% sure you truly have that disease, right? So this test, again, is good at interpreting a positive result. But if you tested negative, right, you're in this box here. If you tested negative, I'm only 50% sure that you really don't have the disease. I'm not that quite confident if you were negative that you don't have that disease, okay? So that's the other describing characteristic. Again, your sensitivity and your specificity, that's kind of what you're using to choose tests, right? Do I want to rule things out? I'm looking for a very sensitive test. Do I want to rule something in? I'm looking for a very specific test. On the other hand, now that you've ordered the test, they go, doc, hey, I got a positive result. Does that really mean I have the disease? Yeah. In this case, 90% sure you have that disease. Hey, doc, I got a negative result. That means I don't have the disease, right? Well, if you ordered this test, I'm not quite sure. So these are going to be your testing characteristics. So as you go through your clinical practice, you're going to see plenty of tests. And it's important to ask yourself, what does a positive result mean? And what does a negative result mean? Again, the 4 tools you're using to describe this is going to be your sensitivity, your specificity, your positive predictive value, and your negative predictive value. Okay? Thank you.